Here is the biggest difference between skeletal muscle contraction and cardiac muscle contraction. Skeletal muscle contraction, if a muscle fiber gets a message from a somatic motor neuron, that muscle fiber is going to contract. And in fact, the whole motor unit is going to contract. And the tension generated by the contraction in the twitch in the skeletal muscle fiber, that tension is going to be the same every single time, assuming we keep length the same and assuming that we keep time, like we aren't changing the frequency at which we generate stimuli. Did you follow that? Because skeletal muscle cells can reach tetanus, which means they can increase the amount of tension that they can generate if you fire them multiple times and very quickly. You don't allow them to relax in between. We already know that cardiac muscle cells cannot generate tetanus because of that giant long plateau, which is a refractory period where you cannot generate an additional action potential during that time. This is different. This is a concept by which you can send a message to the heart and you can activate one cell. Here comes the action potential. It's coming down. The size of the action potential is the same. The movement of ions that create that action potential, it's the same every single time. But the size of the contraction can change. And you know what it's based on? It's based on calcium. If you change the amount of calcium that comes in from the extracellular fluid, you can change the size of the contraction. Now think that through for a second. How could you change the amount of calcium that comes in through the extracellular fluid? Dude, this is like, let's start thinking about mechanisms by which maybe the sympathetic nervous system might dump some chemicals on the cardiac muscle tissue if there are proper receptors on the cardiac muscle tissue for epinephrine or norepinephrine. Those receptors might open additional calcium channels into the T-tubules, which would allow more calcium into the extracellular fluid, which would allow more calcium to get out of the sarcoplasmic reticulum, which would allow more calcium to bind to troponin and move tropomyosin and change the myosin binding site. So voila, we get a contraction. Did you follow that? The amount of calcium, we can change it and change the size of the contraction itself. This is one of the reasons why calcium is a big issue when we're talking about blood pressure, and because we're talking about the size of the pump, how much force is being generated by the heart. Decrease the amount of calcium, we can generate a smaller amount of pressure from the heart by creating the force. The beat becomes smaller. There is another way that your awesome heart can generate different sized contractions. More force, more pressure. Less force, less pressure. There's another mechanism. One of our mechanisms is to change the amount of calcium that is in the intracellular fluid. That's one mechanism to change and modify the size of the cardiac muscle contraction. I'll be right back to tell you all about the other one.